Good morning, Tahmina Khan is here. This is video number 4 for solving past paper questions for permutation and combination, which is the topic of O-level add maths. And before I start, you can see on the top I have mentioned my blog address on which you can find the links of all my earlier made videos. Beside that, there is a Gmail email address, TKMaths fun. Please notice there is no is in it, whereas on the blog there is gmail.com. So if you want to send a message and want to request for any particular question or video, you can send the mail or you can write in the comment box on this video. So let's just start with this question. All these are past paper questions but not of recent years. Okay, so this question is about a competition which has first, second, third and fourth prizes, and there are 10 competitors who have entered their name for the competition, and the prizes are awarded for the first, second, third and fourth in the order of merit. Okay, so first question is find the different ways in which these prizes could be won. So there is no restriction, but you know first, second, third and fourth mean order is important. So now what it will be, can you think? So it will be 10, yes, P and 4, because there are 4 prizes and there are 10 competitors. So 10p4 will give you the number of ways in which the prizes could be won by those 10 competitors. Now second question, there are part 2 and part 3 which is related to some restriction. Smith and Jones are 2 of the 10 competitors. So they are talking about 2 particular competitors, Smith and Jones. Find the number of different ways in which the prizes could be won if neither Smith nor Jones win a prize. So both of them did not win a prize. So what comes in your mind? What will you do? It means total are 10, right? So if these 2 are out, how many are remaining? 8. So the prizes will be won from those 8 people. So it would be 8p4 because we have to select 4 people from the remaining 8 people. Neither John nor Smith wins. So there are 1680 ways. Now the last part of the question was saying I have written this question here again, each of Smith and Jones win the prize. Now this question is not attempted correctly by most of the students. So before I show you the solution and explain it to you, you tell me what will you write for this solution for this question. So both of them are winning. So it means from the 10 you will minus and remaining people are 8, right? So from the 8 you have to select only 2 more people now. So what will you write? Let me show you. So if you are writing 8p2 52, then the answer is wrong. Can you think why the answer is wrong? Jones and Smith are already in the winning team and there are 4 people who are winning. Remaining are 8. From 8 I have to select 2. So if I give 8p2 and p I am selecting because of the position, so this question is wrong. Do you know why? It's because when you are doing 8p2, you are considering all the ways of only those 8 people, AB, BA, CD, CA. What about Smith and Jones? We have given them fixed position. So this is not possible. So you know what is the right solution for this? See here. Actually, you know that Smith and Jones are in the winning team, but what position they are getting, you don't know. So let's select from remaining 8 people first of all, 8C2, which is 28. So there are 28 ways to select 2 people from those 8 people. And then 4 factorial is to arrange them in different positions. So it will be 28 times 4. Let me explain to you here. For example, in every team, Smith and Jones are here. Beside that, 2 more people from the remaining 8 people. So they may be AB, BC, so SJBC, SJDE, S, J, E, F. So you will find 28 ways here, which is represented by this 28. Now, what is this multiply by 24? Why? Because when I say 4 factorial, so once I select this, right, S, J, A, B, so in how many ways I can arrange S, J, A, B? Because these 4 people will get a position. So maybe first position, second position, third, fourth, maybe J, S, B, A, maybe A, J, S, B. So in this way, there are 24 ways you can rearrange them. Similarly, there are 24 ways you can rearrange them. 24 ways to rearrange them. So that's why we are doing 28 times 4, which is 672. So if Smith and Jones are in the team, then in how many ways you can give award? It is 8C2 into 4 factorial. I hope it is clear. This was question from June 98. Now I will take a question from June 2002. Okay, this question is related to digits. There are 6 digits given to you, 0, 1, 2, 3, 4. There are 2 parts of the question basically. This was, these are 2 different questions. Sorry, by mistake it is erased. This is part A and this is part B in June 2008. Okay, so these are 2 different questions. So there are 6 digits and you have to make a 6-digit number, but it should not start with 0. So what should be a technique? Can you think? Let's see. Suppose I am making 6 blanks. You can see here 1, 2, 3, 4, 5, 6. Now the condition is that the first digit cannot be 0. So how many digits can come here? From 1 till 5. So you have 5 possibilities for this position. So what will you write? 5P1. And the remaining digit are 5 and there are 5 places. So that's why you will write 5 factorial. So 5P1 into 5 factorial. Now the second part of the question was saying okay, a committee of 4 people is to be chosen from 4 women and 5 men. So altogether they are 9. And the committee must contain at least 1 woman. Calculate the different number of ways. So what comes in your mind? There are 2 ways. One is little lengthy and the other is short. So I'll explain you both the ways, right? Because everybody thinks differently. So to broaden your vision or the thought process, let's consider both the things here. Okay, so altogether there are 4 women and 5 men, 9 people. You have to select 4 and at least 1 woman should be in the committee of 4. Okay, so 1, 2, 3, 4. So the longer method is at least 1 woman mean maybe 1 woman, 3 men, 2 women, 2 men, 3 women, 1 man, 4 women, 0 men. So we will consider all these cases. See here, 1 woman, 3 men. So how many women are here? 4. So 4C1 into 5C3 or plus 2 women, 2 men. So 4C2 and 5C2 because men are 5. Or I told you whenever it is or, it is addition. If you can understand logic, it's fine. Otherwise, this is also one way to remember it. 3 women, 1 man. Total women were 4. So 4C3 into 5C1 or 4 women, 0 men. 4C4 into 5C0. This is the case which mostly students forget to mention. So and then you can find the answer. Okay, so after calculating, you have found that answer is 121. What is the other method? I was talking about there are 2 methods. So all the cases which we have considered, which case we haven't considered here? Can you tell me? Yes, we did not consider the case of selecting all men, right? Because we were saying in the committee there should be at least 1 woman. So what about that you take all the possibilities and minus the cases of only men selection. So remaining will be your answer. Let's see. all possibilities minus committee of only men. So all possibilities is 9C4 because 4 women and 5 men are total 9, and from 9 we have to select 4, and minus only men. So answer will be 121. So this is a shortcut or shorter way to solve it. Let's see another question. Now this question is from June 2003, paper 2. It's mentioned here. Okay, so there are 5 parts altogether, and the question is saying there is a word Mexico. Can you see? MEXICO. Find the number of different arrangements of the letter of the word Mexico. So this is first part because there is full stop. So no condition, nothing. So you have to arrange all 6 letters. So what comes in your mind? 6 letters, 6 ways. I mean, 6 dashes basically. So what you can write straight away? 6 factorial. So basically there are 6 dashes and 6 places and 6 letters. So you can write 6 factorial. Okay. Then question is saying find the number of these arrangements which begin with M. So you have to still make an arrangement of all 6 letters, but now it should start or begin with M. So what comes in your mind? Let's see here. And by the way, you can put the video on pause and try yourself on the copy or mentally and then start so that you can check your own understanding as well. Okay. So now if it is beginning with M, here are 6 dashes, 1, 2, 3, 4, 5, 6. Now the first place is fixed with M. Now this is very important. When you fixed a place which is not movable, then you just do not consider it. Put it there, the letter or the number, whatever, digit I mean, and then just suppose it is not there. So what is left now? 5 digits and 5 places. So straight away it will be 5 factorial. So all the words beginning with M using the letters in the word Mexico. Now what is the next question? Next part of the question. Now you are not using all the 6 letters, rather 4 of the letters of the word are selected at random. So you will select only 4 letters. Find the number of different combinations if there is no restriction in the selection. So I think this is a very easy question. What comes in your mind? Oh, sorry, I forgot this part 3. So we will come back to this. So part 3 is saying find the number of these arrangements which have the letter X at one end and letter C at the other end. So now again you are fixing the positions of X letter and C letter. So it could be at either end, maybe X starting or maybe X at the end. So let's see the cases. Okay, so here are 6 letters. 1, 2, 3, 4, 5, 6. So first of all, I'm considering the cases when X is in the beginning and C is in the end. So these are fixed. Forget about them now. They are there. So what is not, these are not movable. So what is movable? The remaining 4 letters. So there are 4 possibilities for them to move and 4 letters. So it is 4 factorial. Do you think it is a complete answer? No, it's not. Why? Because C can be in the beginning and X can be in the end. So exactly same situation. So that's why we will multiply 24 by 2. So total possibilities are 48. Okay, so coming back to the question which I by mistake started first. Okay, now we are selecting 4 letters, right? So how many different combinations we can make from the 6 letters? So I think this is a simple case which is 6C4. Okay, so it will be 6C4 when you are selecting 4 letter from 6 letter and making different combinations. And last part is saying letter M must be selected. Now letter M must be selected among those 4, but what is the place of it you don't know. Is it written here? The letter M must be selected, and place doesn't matter because we are talking about selection here, right? So Suppose there are 1, 2, 3, 4. So M is selected, and so remaining 3 more letters I have to select from remaining 5 letters. So 5C3. Let me tell you again here if you are making mistake. In the earlier part, when the question was saying the arrangement start with M, so we put it here and fix it, and then we use P for the remaining, right? We use 5P4. But here we are not using it. Why? Because this is a selection. We are not talking about first place, second position, or third place. So M is selected. Now remaining 3 have to be selected from 5. So 5C3. So answer is 10. Okay, so let's see the last question of this video. It is also a past paper question, but I don't remember which here. So it is saying each of the 7 children, so they are talking about 7 children who are throwing a ball at the target, and calculate the number of ways the children can be arranged in order to take the throw. It is actually throwing, just throwing, right now. First part is only talking about throwing. So 7 children, so anyone can come first. Then if first child has thrown, then how many are left behind? 6. Then how many? 5. So what comes in your mind? 7 factorial. So number of ways children can be arranged in order to take the throw, right? Next part of the question is saying, which is at times little difficult for students. It is given that there are 3 girls and 4 boys. Now when they are throwing, it has to be successive throws, alternate throws. Okay? So it should be, if it is alternate and successive throws are made by boys and girls alternatively. So what do you think? What it should start with? It should start with a boy. Why? Boy, girl, boy, girl, boy, girl, boy. So now it is alternate. If you will start with girl, they will finish here and the last 2 will be taken by boy. So it will not be alternate. So number one thing is that you need to understand that it is starting with boy. So before I show you the solution, I have just shown you this visual understanding of it. So basically these positions, first, third, fifth and 7th, will be taken by boys. So positions are fixed, but which boy come here out of 4? Anyone? Now 1 boy has thrown, so here 3 are left, then 2 are left, then 1. So for boys I can write 4 factorial. Similarly, these positions, 2nd, 4th and 6th, these positions are fixed for girls. But which girl will come here out of 3? I don't know. So 3, then 2 and then 1. So it is 3 factorial. So when you are doing successive throws and they are made alternatively by boys and girls, it will be 4 factorial into 3 factorial. So thank you very much for watching this video. If you have learned something or you find it is useful, please press like and subscribe button. You will get indication of my new uploaded videos. Take care. Allah Hafiz.